Thanks all for having me. It's wonderful, I think, to speak at an OWASP event. Because normally I speak at a more governance, risk, security offer type event. So it's glad to see a lot of expertise in the room. It's also good to see some familiar faces. Feels like a reunion at times. I can still remember when I followed in the footsteps of Martin at A1, where he started this journey, by the way. He was the first one. And also we have Jeroen in the room, who is now continuing this story. So it's a small world of security. But it's really nice. So thanks for having me. We are going to talk about secure DevOps, DevSecOps. So who here in the room is working as an engineer or a developer in a DevOps team? So probably not going to tell you anything, probably. So who here is more in a risk security officer role? Okay, so hopefully this will bring something new for you. But the reason why I call it secure DevOps is before you know it, we will have Dev HR Ops, Dev AI Ops, Dev Financial Ops, and everything that you have to do when you're running a team. So it's just doing DevOps security. That's why I like to call it secure DevOps. And this is definitely how some of my security engineers or some of my security officers see their role in their organizations. We have a bunch of unicorns, people that are hard to find, full stack developers, and they also have to be security experts, etc. And this is how a lot of my peers see those people that are working in those teams. And have to clean up after those unicorns. And I think that threat modeling plays a huge role in not producing magic rainbows for those teams. This, however, is how I see DevOps, secure DevOps at least, where it's a team effort, where you contribute with threat modeling, where you contribute with knowledge, you participate in their team events, for example, whether that's a sprint planning, or whether that's a post-mortem, or whether that's a planning session, etc. So who am I? Well, this is me. I'm a father of 2 girls. I'm a freelance security officer, currently working for the National Cybersecurity Center in the Netherlands. I'm their CISO. I was their security architect previously, where I had the pleasure of working on their data and analytics platform. So a lot of data engineers and some AI, definitely some machine learning in there. If you want to know a little bit more about me privately, I lift weights. I like to swim, bike, and run. We call that a triathlon. So that's a future Ironman somewhere, someday, hopefully. Probably next year, not this year, because I love food, drinks, and quality time. And that is also not compatible with having future Ironman goals. Also, I need to lose a little bit of weight before I can actually participate, because you have to carry all that weight during that event. Nothing beats vinyl, and I like to read books. That's about me. So I like to change the way my security peers in our industry work. I like to change the way they secure information, and I like to do that by ensuring their information security in an agile way. Because I think we, at least my peers, all use waterfall methods a lot. So, a quick introduction. What I think application security is, and challenge me on that when we are having drinks or at lunch. What I think is every activity that you need to perform to ensure that your software is secure. And it's not my quote, but it's a quote from Tame. She speaks on this subject also a lot, so I highly recommend that you look her up. And I think it's really needed. I think application security is a huge problem in our industry. If you look at, for example, the Horizon 2020-2002 data breach incident report, you see that 70% of all breaches have a web application security cause. Now we can talk all about SQL injection, cross-site scripting, whatever you want, but most commonly it's just weak password policies or the lack of 2FA. So let's get the basics right. Let's get the basics right first. And I think it's a huge problem. And that's largely also due to the fact that the majority of security departments are outnumbered. So this story is about my story at Elan. This was not the exact ratio. We had about, I think, 200 people in development at that time. I think about 50 people in ops. And I think the security team back then was about 10 people. It's really hard to find the right people to scale up. Definitely if development teams become more agile, release more frequency, and have a high velocity, it's really hard to keep up. When you also have to do your compliance requirements, not everybody on your security department has coding skills or know a lot about engineering. Some people just know a bit more about policy or risk management, so it's really hard to scale up. And sometimes, even with those numbers, because I know that there are a lot of organizations where they have like 1 or 2 people working in security, it feels like you have to do it all, right? It's a little bit like, it feels like this. I'm not sure if you know this. You have to do it all. I think you get the point, right? And then again, a lot of these companies also were used to using the waterfall method, and that really never worked very well. It was a model that introduced quality gates or gates where security needed to improve something. It led to things being tested at the end of the development cycle. It created a lot of tension between the teams, where there was a product manager who said, I want to go live next week. And then did you talk to security first? Did we do the threat model? Did we give you requirements? Is everything HTTPS? You encrypt the data? It's like, no, but we want to go live next week. Then you needed to, like, at least in Egon's case where I was working, we needed to consult external security testers. So we had to go third party for penetration testers or ethical hackers. They have a lead time for 6 weeks. In the meanwhile, the product manager wanted to go live 7 weeks ago. Then there was a report saying you have a couple of high findings, you still can't go live, you need to fix those. So it created a lot of tension. So these waterfall methods never worked. And I think that investing time or creating a secure DevOps culture within your company actively contributes to earlier feedback from your developers, increased time to market, etc. So that's why I think a lot of these models really don't work. So secure DevOps. What is secure DevOps? I took a quote from Imran. He said, performing application security in a DevOps culture. And I think that's key. It's not about technology. It's not about processes. It is definitely a little bit about people, but when you combine those three, I think you get a culture. Right? It's really a culture that you need to increase, or a culture that you need to develop within your development teams or within your company. It's not just, okay, we have a tool, do this, and then you're good. It's not a process that they should follow, because we learned from the previous speaker, teams will probably adapt the process or do things a little bit differently than was firstly intended. And it's definitely about people, but also not just about people. So I would say the main goals of secure DevOps, hopefully this reads a little bit better on the slides, but it will have a lot of benefits, right? So if you do things in a more DevOps way, then your deployment frequency will be higher. That also means that the business can release products sooner and new features sooner, but it also means that from a security perspective, you can release fixes sooner. So products will become shorter vulnerable. What's that? Not so long vulnerable, I think, because you can fix it faster. You have a lead time for changes, so that becomes shorter as well, which also means faster fix and more resilient. Time to restore the services. If you look at companies that have a DevOps culture and are high performance or are considered high performance, you will see that they have faster time to market, but also more resilient because of the fact that they can restore their services very easily, right? So that means that, for example, the recovery time objective of your services, if it's a critical customer service, will become shorter and downtime is less. And your change failure rate, because you deploy not every 6 months, but also, for example, every day. If you do that more often, people get more experienced, so changes will probably go better if you do that, right? So, let's speak a little bit about the quest we had to what I call taming the DevOps unicorns at Aegon. So, this is the part where I would like to share the lessons that we had, and hopefully you will take that back to the companies and organizations that you work for and not make the same mistakes. So I like to call this, there are no heroes in security DevOps. So when I just joined Aegon years ago, Martin was there. He was the hero of Aegon back in the day. Yeah, you were. You were the only security officer with actual application security knowledge. And everybody looked to him for advice and to guide the teams in creating secure software. And it's not a one-man job, right? You need to foster the culture. It's a culture change. You really need to work with security champions, something that I heard in the previous from previous speakers as well. So what we did wrong at first was there was only one security officer pulling on a dead horse, saying this needs to change. We need to develop secure software more. Or we need to develop more secure software, etc. So we started working with security champions. We organized events for them to educate them, to teach them. For example, brought in speakers, people who did bug bounty projects. We organized a internal bug bounty program or capture the flag event. So I talked to one of the release train engineers. I said I would like to have a week of time from all developers, and in that week they can hack each other's products. So I gave every product manager 10,000 euros in fake money, and there was a whole pathway, I guess, to that event. We had people explaining, bounty hunters explaining what cross-site scripting was, what SQL injection was, how they could test for it, how they could find it. We gave them instructions, videos, etc. And then in that week, they could hack each other's products. So that meant that teams were always looking at the Java monolith because it was easy to find a lot of vulnerabilities there. But in the end, it created a beautiful exercise, I think, for the teams because developers were looking at each other's products, were hacking each other's products, were learning how to test to find vulnerabilities, and it made product managers very aware because what would happen was that if a developer found a bug or a vulnerability, it came to us for like triage, to do any normal bug bounty program. What have you found? Oh, looks good. I think this is a valid finding. He awarded 1,000 euros. Go talk to product manager Rob to claim 1,000 euros, and then he had to get 1,000 euros from that product manager. And then at the end, they could use the fake money to spend on actual products, like a Nerf gun or a case of beer and chips or an escape room thing that they could do. It was really nice. So leverage events, leverage knowledge transfer, leverage security champions, train them, organize nice events, make use of OS juice shell, for example. I think that is also very good to do. And if you have the money, spend it on actual training. I think this is very important, at least to us. You should really know your organizations and your organization and the assets that you're protecting. It will actually get you buy-in more easily from management if you know that you're not going to do it for your entire organization, but you say, "We'll just focus on the most critical applications that we want to do." I think that's very key. Something that we learned is that as a security department, do not dictate how developers work. So, know their way of working, actually visit them, sit in their area where they work, talk to them, figure out how they work, and let them also determine the tooling that you're going to use. There are a lot of vendors here. There are a lot of vendors everywhere. There's open source tooling. But focus on capabilities. So I would say if you want to do static application security testing or dynamic application security testing, then focus on that. Talk to the teams. Say that this is important for reason X, Y, and Z. Explain to them. They will fully understand. But figure out if the tool that you're going to use, for example, if it integrates easily into the development environment, in the IDE of the developer. Make sure that is possible. Learn how they work. Are they working with Jira? Is the tool that you're using actually able to log tickets into Jira? Or do they have to log into some external dashboard and need to figure it out and then copy paste it themselves into Jira? So this is very key. And another thing that I found is who in the organization is going to maintain the infrastructure that you are building if you are choosing for on-prem capabilities. So what we did wrong at first is we chose a vendor. We implemented their software, the static application security testing on-premise. So it required servers. It was maintained by an IT for IT team. But that IT for IT team has absolutely zero knowledge about static application security testing. The security team was somewhat of a functional owner for that application, so it would define policies, it would create projects in it, it tweaked the functionality of the static application security testing tool. But in the end, the underlying infrastructure is something that an IT for IT team wasn't committed to. They were committed to containing Confluence, to Jira, to the Azure DevOps pipelines that we were using. So when it came to upgrade, for example, to a new version of this tool, which was their responsibility, it took them months to do because it wasn't a priority for their roadmap. It was on infrastructure that they knew basically nothing about because they didn't work with it on a day-to-day basis. So my advice here would be, when in doubt, go cloud, because that will discharge your organization of your of maintaining the infrastructure, and it will give a security team the responsibility to work on the features or on the functionality of the application and settings. And another thing, if your secure DevOps program becomes a success, then you need to scale it. And that is also something that we run into and became more successful. We needed to scale the service, and that also took a tremendous amount of time to do. So that's why I also say when in doubt, go. Then know thy weapons. Know the tools that you're using. Don't rely on Gartner models and other stuff, but fully understand what they are doing. Fully understand the functionality that it has. Fully understand their license model. So we experimented with a tool that had a license per developer model, and it came with some project and pipeline restrictions, but it also had a repo model as part of the license model. That meant that if you are doing microservices and a team has like 265 microservices, because they were phasing out the old mainframe to more microservices-oriented platform, then the license fee increased tremendously, which wasn't really a nice thing to have a discussion with your management about, because you just were full in on a tool, and then you found that one team that has 265 microservices. You have a challenge. Definitely limit unnecessary scanning. So static application security testing, in my mind, should only audit the code your devs write. So not the code that they use from third parties, not their external dependencies, not their libraries that they use, only the code that they write, because otherwise scan times take too long. And software component analysis is something that you would use for the third-party dependencies, for the libraries that they use. Quite often there's a known vulnerability in there. You should really do static application security testing. Leverage known vulnerabilities and block the usage of them as, for example, a high or medium vulnerability. And definitely let your developers run all the tools that they use locally. So make sure that they can use it from their workstation. So, developers want to have an early feedback loop. I think a feedback loop in a CI/CD pipeline is great. It's something that you should have, but in my experience, a lot of developers still don't want to commit code and then learn it. If a CI/CD pipeline is running, they want to know it at their workstation, on the laptop or computer. Definitely start slow. It's a quest, not one battle. I wouldn't recommend implementing multiple security capabilities at once. So don't implement SAST, DAST, container security testing. It will create a lot of noise. The change is too big, and you still need to tweak every single capability that you're releasing. So we started with SAST, DAST, software composition analysis, and we did some infrastructure as code audits as well. It was simply too much. Really, I would say focus on static application security testing first, and then really focus on 3 KPIs. So false positive reduction is definitely key. You don't want to lose the developers by overwhelming them with a lot of false positives. So make sure that the project they're using is scanned multiple times, that you tweak the false positives as well, that everything that they get is a solid finding, a solid vulnerability. Monitor the scan execution times. So sometimes you have this one project or this one team that has an application, and for some reason the scan execution time goes from minutes to hours. So you should really monitor that. If it's out of the norm, you should really dive into that with the team and maybe even external expertise to find out why it's taking so long to scan. And code coverage. So code coverage is another metric that you need to monitor vigorously. And then I think the most heated discussion, at least when you're working for a financial, when are you going to break a build? When are you going to stop the teams? And you can imagine that in a company where the risk tolerance isn't that high, if you would say to management, we have a high vulnerability, but it's fine. We just looked at this 3-year-old application for the first time and we find 30 high vulnerabilities. It is going to go to production. It's been there for 3 years, 2 years. That is probably not a statement that you can make. You need to have a pathway to address those vulnerabilities. But you can also not say, we're going to limit that application from going to production and the teams needs to fix it first, because then you will have product managers and marketing teams that will not like you a lot. So what we did is we defined dynamic thresholds. We scanned it for the first time. We did the false positive reduction. Say the high vulnerability numbers were 30. We would say, okay, you can't introduce a new vulnerability, and the next time that you release, it needs to be 29. It needs to be 28. That will become the next threshold every single time. And I think a lot of product teams can commit to solving it if they can still go to production and they can't introduce new stuff. And also management can agree to the fact that you have a plan where you are addressing what you've found. And also fail intelligently. So you can tag your builds with no release to production and then create a work item in Jira for that. So you would say, hey, this build has failed. You can't go to production. You need to fix X, Y, and Z. And then last but not least, you will become a victim of your own success. At least we did. At some point, the legacy apps were coming. We had one Java app with 1 million lines of code. When we first scanned it, there were 60,000 security vulnerabilities in it. Yeah, that was fun. Not to mention that the entire pipeline was down and my SOS went down, etc. So it was all built to scale up would be my next advice. And when in doubt, go cloud. And definitely consider a separate pipeline for static and dynamic application security testing. Yeah, famous last words, as in all presentations. Do good on time. So implementing a secure DevOps culture is definitely hard. And I think we all need to accept the fact that we're going to fall off that unicorn. Previous speaker also said, you're going to fail. You need to adapt. So just take a deep breath. Jump on that unicorn again. Adapt. Be agile as a security professional. Don't hang on to too much compliancy frameworks or legal frameworks. Be agile. And then eventually, I think after 2 or 3 years, you can say that you have tamed those unicorns.